All right, here's problem 8 about complex numbers. And what I want you to think about is it's a system of equations. You've got two unknowns, w and z, and two equations. So you should be thinking of doing either substitution or elimination on this problem. And I noticed that the first equation here is almost ready to be substituted. If I multiply by z, I get w equals 2iz. And then I can substitute that value right into my second equation. So I have z star minus 3w, which is minus 3 times 2iz, equals 5 plus 5w, or 5I, excuse me. The next thing to do is to break things down in terms of a and b. It even tells us to do that here. Find w and z in the form a plus bi. So I'm going to say that z equals a plus bi. Z star is usually, I've seen it written as z with the bar on top of it. It means the conjugate a minus bi. So let's write everything out in terms of a and b. A minus bi minus 3 times 2I times z, which is a plus bi, still equals 5 plus 5I. Now it's just multiplying and gathering everything together. So a minus bi minus 6ia, that's 3 times 2I times a, and then minus 6I squared b. Now remember that I squared is equal to negative 1, and so this last term right here is actually going to be a real number. I'm going to gather my real numbers together. A plus 6b, a plus 6b, those are the real numbers. And I'm going to gather my imaginary numbers together. Minus bi minus 6ia, or 6ai, equals 5 plus 5I. The nice thing about complex numbers is they are only equal if their real parts are equal and if their imaginary parts are equal. So we can really split this up into two separate equations. The purple equation becomes a plus 6b equals 5. And the pink equation becomes negative 6a minus b is equal to 5. So a couple ways you could approach it here. You could multiply the purple equation by 6 and write 6a plus 36b equals 30, and add those together, and then you have 35b equals 35, telling you b is equal to 1. Once you have b is equal to 1, you should be able to see that a has to equal negative 1. Now we're almost done. We know that z was equal to a plus bi, so we know that z equals negative 1 plus bi, which is I. And we know that w equals 2I times z. So w equals negative 2I, because that's 2I times the real part of z, and then plus 2I squared. The last thing we'll do is just fix up w. The 2I squared is actually a real number, and so I'll just go over here to the left side. W equals, what would that be? Negative 2 minus 2I. Z, we already figured, negative 1 plus I. So really, this is kind of putting together your old systems of equation skills along with your complex number skills. There's other approaches to this problem too, so just let me know if that one didn't click and you want me to do it a different way. Thanks.